Welcome to the webinar Train Machine Learning Models Better, Cheaper and Faster using Amazon SageMaker Debugger. My name is Natalie and I am an applied scientist at AWS. First, I would like to discuss briefly why we need to care about debugging and profiling. When we train machine learning models, then this is typically an iterative process where we try out different model configurations, different datasets, different hyperparameters. And it may quite frequently happen that we end up with models that do not generalize or that start overfitting. So we may have training bugs in the training script, and trying to find the root causes of such problems is not always easy. And for sure, it's very time consuming. When you train machine learning models, especially deep neural networks, then they are typically trained on large compute instances. Trying to use these instances as efficiently as possible is not always straightforward. And typically, training machine learning models takes also a long time because they have to be trained on large data sets. And because of that, we want to ensure that we find training bugs as early as possible and use these instances as efficiently as possible so that we can make the most out of our training budget. Now I would like to show you how you can use SageMaker Debugger to address the debugging challenges in the machine learning lifecycle. SageMaker Debugger is a feature that allows you to automatically capture tensors from your model training. We have modified the SageMaker DLC containers so that you as a user do not have to modify anything in your training script nor in your model. You simply specify the kind of tensors you want to have emitted, tensors such as weights, gradients, and Debugger will take care of the rest. The data will be captured in real time and uploaded to your Amazon S3 training bucket. Debugger provides a new feature, a profiling functionality that you can use to capture performance metrics from your model training to identify issues related to computation and performance. We monitor metrics such as system utilization, like utilization on CPU, GPU, memory, network, and I/O. And you also have the possibility to profile GPU kernels. Debugger provides automatic error detection. It provides built-in rules, and you can also write your own custom rules that fetch the data and check for issues such as model quality issues. For instance, if your model is overfitting, underfitting, or suffering from vanishing gradients. And we also provide a whole new set of rules, profiler rules, that can now identify performance-related issues. For instance, if your training is underutilizing the resource. We also have a new feature that allows you to define alerts and actions. So for instance, if a rule triggers, you can auto-terminate the training or send notifications such as email and SMS. With the profiler rules, we also provide now a profiling report that gives insights into the kind of performance issues that Debugger detected, and also recommendations of next steps. You can also use Debugger for real-time monitoring and visualization, and that's especially useful if you have training jobs that run for a long time. You can inspect the data in real time, either via the Debugger API, which you can use in your notebook, and you can also use SageMaker Studio to visualize the performance data in real time. Now let's take a look on the architecture. When you run a training job on Amazon SageMaker, then it's running inside a training container. Debugger will make sure that the tensors you have specified will be automatically emitted at the Amazon S3 training bucket. And if you have specified rules, then the rules will run on a separate instance in a separate container. This means that the rule analysis does not interfere with your training. You can run an arbitrary number of rules in parallel, and you do not pay for the execution time of those rules. The rules will use Amazon Simple Notification Service to provide notifications such as SMS and email whenever the rule triggers. The rules also emit metrics to Amazon CloudWatch, so you can specify a CloudWatch alarm that then triggers a Lambda function, and you can specify any kind of functionality within this Lambda function. You can also use the real-time monitoring feature. So the data is uploaded in real time. So while the training is still in progress, you can go to your notebook and use the Debugger API to visualize Tensors and performance metric, or go to SageMaker Studio to look at the performance data. Now I would like to go to the demo. But before I jump into the notebook, I would like to highlight that SageMaker Debugger provides a lot of different functionalities that serve the needs of beginner as well as expert data scientists. And based on that, I will cover different use cases in the demo. And first, I would like to give a brief overview of these use cases. In the first use case, we will look at how we can use Debugger to collect tensors and automatically identify bad training jobs using the available built-in rules. In the second use case, we will collect performance data and see how we can identify resource allocation inefficiencies by looking at the profiling report as well as SageMaker Studio. If you are a data scientist that is running experiments with a large number of training jobs, then you will find the feature of taking actions on rules very useful. You can set up experiments and specify different actions for different rules. For instance, you can auto-terminate training jobs that would otherwise produce low-quality models. That allows you to save time and cost. In the use case 4, we will look at how you can use Debugger in combination with SageMaker Experiment to visualize training metrics such as loss curves. And we will also look at the Debugger API that you can use in your notebook to visualize tensors such as distribution of weights and gradients while the training is still in progress. If you are an experienced data scientist, then you may find yourself in a situation where you want to write your own custom rules. And I will show you how you can do that in use case 5. These custom rules help you to define your own custom logic that is specific to your machine learning model and use case. In the last use case, we will look at the XGBoost report rule. It's a very new rule that we introduced that allows you to automatically create visualizations for your XGBoost model training. So now let's go to the demo. So in use case 1, I would like to show you how you can collect tensors and automatically identify poor training jobs. As I mentioned in my introduction, Debugger can capture any kind of tensors from your model training. It can capture, for instance, the model imports, the gradients, the weights, activation functions, and it can detect issues such as neuron saturation, overfitting, poor weight initialization, and many more. The first step is you use the SageMaker Debugger Python module, and from there you select the rule configs package. The rule configs allows you now to access any of the available built-in rules. As I mentioned in my introduction, we provide built-in rules to find model quality issues, for instance, class imbalance, confusion matrix, dying ReLU problem, and many more. And we also provide profiler rules that you can run to data mine bottlenecks and other resource underutilization issues. Here, I'm selecting now the loss not decreasing rule. I use the rule configs and select loss not decreasing. In the next step, I'm specifying a debugger hook configuration. And that's useful if you want to collect some additional tensors from your model training that are not already collected by your built-in rules. So for instance, in my case, I want to collect the weights, the gradients, which are default collections provided by Debugger, but I can also create my own custom collection, and that's what I'm doing here. I just have to specify a name for this collection, and then I specify a regular expression of the tensor names I want to have included in this custom collection. So now that I have specified the rules and the debugger hook configuration, I can now go and start my SageMaker training. When you run SageMaker training via the Estimator API, I use here now the PyTorch estimator. In order to enable debugger, you only have to pass in the debugger hook configuration and the list of rules you want to run. The training script that I'm going to run is defined in train.py, and I want to run the training on a P2 instance. Now, when I call estimator fit, SageMaker will automatically spin up the training container, and Debugger will take care that the tensors I've specified, the weights, the gradients, and the model inputs, will be automatically emitted to my Amazon S3 training bucket. SageMaker will also spin up the rule containers for the loss not decreasing rule that will fetch the data from Amazon S3 and then run the analysis while the training is in progress. You can now go either to SageMaker Studio, or in the notebook, you can check the rule status via the Python SDK. You access here the estimator object, and then with latest training rule job summary, you can see the status of the rule. In my case, it tells me that an issue was found. Now I would like to go to the use case 2. Now we will look at how we can use Debugger to capture profiling information. Debugger captures metrics such as utilization per CPU, GPU, I/O, network, and I/O. And it provides what we call framework metrics. These are operations that are run within the training script, such as the time of data loading, data preprocessing, synchronizations between GPUs, and many more. When we look at the machine learning pipeline, then you typically start off with some data sets that are either available on a local or remote storage component, and this data has to be loaded onto the CPU RAM. The CPU is typically performing the data preprocessing and then preparing the batches, which are sent over to the GPU. And then the training is happening, synchronizations between GPU and CPU are happening. And what quite frequently happens is your model training may run into a CPU bottleneck. A CPU bottleneck is a situation where your GPU is waiting now for new data to arrive from the CPU, so the utilization drops. But at the same time, the usage on the CPU is very high because it's busy with preparing new data. It's typically a scenario that you would want to avoid because it leads to underutilization of the GPU, which is typically the most expensive resource. So to capture now these profiling metrics, you can use the profiler config from the SageMaker Python SDK. And in the profiler config, you specify how you want to have the system metrics sampled. In my case, I want to have the system metrics every 500 milliseconds. I then specify a framework profile, and this is for the training operations that are captured from the training script. I want to have them captured from step 5 for the consecutive 2 steps. What Debugger will do underneath is, when it's collecting the data, it will correlate them. So for instance, it's getting the usage per GPU, like here, and we see that sometimes the GPU usage drops to 0%. And with the metrics from the training script, we can now identify what happened at the same time in the training script and try to find correlations. So for instance, in this timeline, we see that data preprocessing is always happening when the GPU utilization dropped to 0%. So it gives me an idea of the potential root cause. Once the training is running, you can now use the studio visualizations as well as the profiling report to get more insights. So let's take a look. In order to open the studio visualizations, you have to go in the SageMaker experiment view, select your experiment, then you have to select the training, and then in training you can click Open Debugger for Insights. And that will provide you now the overview panel. In the overview panel, you will see first how long did your training run, when did it start, how much time was spent in the initialization, the training loop, and the finalization. So when you train deep neural networks, you typically only use the GPU during the training loop. So you want to be sure that this is the time where you spend most time in. The overview panel also provides an overview about the aggregated utilization statistics. This is aggregated by worker node. In my case, I was only running on one worker node. Then you see here the different metrics, network, GPU, And I can quickly see that my instance was underutilized because my median GPU utilization was only 63% and the maximum GPU utilization only 75%. I also see that at the same time, the CPU was not utilized a lot. The median utilization was only 24% and the maximum only 80%. So obviously, I have been underutilizing my training instance. The overview panel will also provide you an overview of the operators that have been running on the GPU, sorted by descending order. And then there will also be an overview of the built-in rules that have been running and which of them found issues. So in this case, the step outlier rule and low GPU utilization rule trigger. In the node overview, you will see the utilization across time. So for instance, this shows me the CPU utilization, and here I see network as well as GPU. I see, for instance, that the GPU utilization was highly fluctuating, and that may indicate some bottlenecks in my training script. You can now also go to the download report to retrieve the profiling report and get some further insights. Let's take a look. So this is the SagMaker Debugger profiling report. It's a static HTML file that is automatically generated while the training is still in progress. It will be regularly updated, and you can find it in your Amazon S3 bucket or download it with your SageMaker Studio. In the beginning, the profiling report will provide you a similar overview about the training job summary, as well as the system usage statistics, then the framework metric summaries, as well as the operators running on CPU and GPU. And all these visualizations are also interactive, so you can zoom in, zoom out, and order the metrics. There's an also rule summary, similar to what we have seen in SageMaker Studio. And then for each of the rules that have been running, there will be some further insights into why the rule triggered and which kind of issues were detected. So for instance, the step outlier rule will measure the step duration. A step in your training script is one forward and backward pass. And the rule will measure if there are certain steps that take a lot more time. So for instance, this histogram shows me now the step duration on the x-axis and how often each step occurred on the y-axis. And the rule triggered because there were now certain steps that took significantly more time than the average step time. Debugger will then capture those outliers and correlate it with what has been happening at the same time in the training script and provide that also in the profiling report. There will be also some further analysis about the GPU utilization. We provide box plots as well as workload histograms. The workload histogram shows you the utilization of GPU between 0 and 100%, and then counts how often the GPU was utilized at 0%, 40, 50%, 100%. And what we see here is that most of the time it's at 0% or at 70%. It never really exceeds 80% utilization. The profiling report also includes a data loading analysis. Data loading is very important to really reach high utilization in deep neural network training. And this analysis includes information about how many CPU cores were available in my training instance. So here I had 8 CPU cores, but I was only running one data loader. So that's something that could have been improved. There's also a histogram that provides me some information about the data loading time. And I can see that there are some outliers, and it's not like a uniform or Gaussian distribution. And then the profiling report includes a lot more information as well about if I could increase the batch size, as well if there are CPU or IO bottlenecks. So now we have seen how we can identify resource underutilization issues. Now I would like to show you in use case 3 how you can use Debugger to take actions on rules. And this is especially useful if you run experiments with large number of training jobs. In each rule, you can specify actions. You use the rule configs and then an action list. And you can select stop training, or you can select email or SMS notification. For this, you have to set up the Amazon Symbol Notification service. You can also run multiple actions per rule. So in my case, I want to have the training stopped whenever the loss not decreasing rule triggered. And the loss not decreasing rule basically checks that the training loss is converging, and if it does not decrease any longer, it will trigger. And then I just pass in the action definition. So I run that on my training script. In my training script, I'm taking a pre-trained ResNet model from the PyTorch model zoo. I fine-tune it on a new dataset. And in my original training, which is the blue curve, I basically run the training for too long. So it ran for 4,000 iteration, but actually after 1,000, the training loss did not converge anymore. So I could actually have stopped the training. With Debugger, I can now automate this action. So I stop the training after like 1,500 iterations, and basically my training run in less than half the time. So I saved a lot of compute cost. And with SageMaker Debugger, I can automatically do this in an automated way. So now let's take a look on how you can use Debugger to capture granular data and visualize them in SageMaker Experiment or in a notebook. So first we will look at SageMaker Experiments. SageMaker Experiments is a feature of Amazon SageMaker that allows you to group your training jobs into an experiment and to associate them with some metadata. In order to create an experiment, you have to use the SageMaker Experiment Python module. Just pip install SM experiments. And then now I create an experiment where I basically just provide a name of what the name for my experiment is. Now, once you have an experiment, you can create trials within that experiment. A trial is basically like a training run. And I'd simply call here trial.create. And I specify the experiment name with which this trial will be associated. And in this helper function, I'm basically returning a dictionary in the end that provides me the experiment name and the name of the trial. And now I want to run an experiment. So in my training script, I'm training an image classification model on a new data set. And now I would like to try out different pre-trained models from the PyTorch model zoo and fine-tune them on my dataset to see which of the models is actually working better for my given dataset. I use here different versions of ResNet models as well as VGG11. So I create here now a for loop where I iterate over the different available models. And in each iteration, I will create a new trial within that experiment. I specify also here debugger hook configuration and rules. And then I start the training where I pass in now this experiment configuration. This allows SageMaker to associate now the training job with the experiment and the given trial. At the same time, I will go to my training script and I provide with debugger some additional metrics. So in my training script, I define here the data loaders. And then here I'm selecting the different models. And then I'm using now the SageMaker Debugger hook. I use here the SMDebug library, which I have installed before. That's basically the open source library that you can use to use the debugger functionality in Debugger API. And I use the hook to now save some additional data from my training script. For instance, for each training run, I save information about a number of parameters in my model. I just call the function hook save scalar and the name of this scalar metric, and then here I save the number of parameters. I also store some additional metrics such as the accuracy of my model during validation phase, as well as the time it took to actually train one epoch on this model. So once I have done that, I can now go to SageMaker Experiment and create some visualization. So let's take a look. In SageMaker Experiment, you select it from here. I can now see my experiment. And in this experiment, I have the 4 training jobs that I have been running. And now what you can do is you can select them and open them in the trial component list. You can open them in the trial component list, where I see now that also the debugger rule status. So for 2 models, the loss not decreasing rule did not trigger, but for the 2 other models, it did trigger. And I have here the metrics that are saved from my training script. You can select them also from this menu here. I see here, for instance, that in terms of accuracy, all the models perform nearly similarly. I see that the epoch time differs quite a bit, as well as the number of parameters. And now you can create visualizations. You just go on Add Chart, and here I'm selecting now timeline chart. My x-axis is the epoch. And then let's look at the accuracy first. I see here, for instance, that the accuracy metric across the different epochs of the validation phase are actually nearly the same. So there's not much difference between the different resonant or BGG11 model. I can now also look at the epoch time. So let's take a look at that. And here, of course, I see a large difference. So the fastest model is basically ResNet 18. It takes a lot less time to train, while ResNet 101, which has a lot more layers, takes a lot more time to train. So obviously, I would want to use ResNet 18 because it achieves the same accuracy and is faster to train. So that's how you can use Debugger in combination with SageMaker Experiment to capture some key metrics. But we can go a step further. You can also use the Debugger API to visualize the tensors in real time. First, you have to install the SMDebug library. It's open source, so you can just do pip install SMDebug, and it provides you all the functionality that you need to read, query, and filter the tensors that are stored in Amazon S3. First, you have to create a trial. The create trial object takes a path to where the tensors are located. And once you have the trial object, you're ready to analyze the data. Let's first take a look on the SMDebug API. The SMDebug API provides different functions. So for instance, with trial.steps, you can see when tensors were stored. Per default, Debugger will only capture data every 500 steps, but you can configure that. You can, for instance, save it every 10, 100, or even every single step. You can also distinguish between modes. So in your training script, if you set a mode for the training and validation phase, you can now distinguish in the steps that were recorded between validation phase and training phase. You can also access the available tensor names that have been collected by Debugger. You just call the function trial.tensorNames. And in my case, because I captured all weights and gradients, the list is actually quite long, so I just print the first 10 tensor names. You can now also filter the tensor names. So for instance, here, I only want to see the weights that have been captured. And in order to access tensor itself, you call the function trial.tensor, and you have to pass in a tensor name. So I just select a name from up here. And then with .value and the step number, you can now access the tensor at a specific step. This function will now return a NumPy array. So I can use tools such as Matplotlib, Scikit, SciPy to analyze and visualize the data. So for instance, here I just plot a distribution of weights. I'm using now my first convolutional layer in the model. And then I pass it into my Matplotlib histogram function, and I can look at the distribution of weights, and I can do that while the training is still ongoing. You can also visualize the loss curves. So here in my model, I have used a cross-entropy loss function, and Debugger captured the inputs and outputs. So here I'm using now the outputs versus the steps that have been recorded, and I want that information for the training phase. So this plots just with a few lines of code. I plot the training loss, and I can see that my training loss did not converge after 1000 iterations. You can also use Debugger to inspect incorrect predictions. How I do that is I'm capturing now my model inputs the predictions, and the labels. And I iterate over all the steps that have been recorded from the validation phase to see where did my prediction not match the label, and then plot the corresponding input image. I'm taking here now the inputs into the loss function, and which are the predictions and the labels. And my resonant input is the image batch that has been recorded by Debugger. And I have this small for loop where I basically always plot the image with the corresponding ground truth label and the prediction when prediction did not match the label. And with this few lines of code, I found an interesting model bug in my model where I had trained it on a traffic sign dataset. And basically what happened, the model would always confuse traffic signs that involve a direction, like turn left ahead versus turn right ahead, or keep right versus keep left. And the model, as we have seen in the visualization, achieved a decent test accuracy, but nevertheless, this looks like a severe model bug. The root cause of that issue is that if you train resonant models, you typically do data augmentation during data loading. Data augmentation such as random crop, random rotation. And this data augmentation typically includes a random horizontal flip if you train resonant models from scratch. And in this situation, what happened is that in a data set like that, where you have some sort of dependency between image classes, it actually caused an issue. And with Debugger, I was able to quickly identify this bug. Now I would like to go to use case 5. So we have identified a severe model bug. And now I would like to define a custom rule that makes sure that I automatically can capture an issue like that. So in order to define your own custom rule, what you have to do is you inherit from the rule base class, and you have to implement one function, that is invokeItStep. In the invokeItStep function, it's called every time new tensors of a new step are available. And I capture here now the prediction and the labels, which are the inputs into the loss function. And like before, I capture now when does my prediction not match the label. And specifically, I want to have it for certain image classes like turn right ahead and turn left ahead, which is image class 34 and 33 in my case. And I want to know how often has my model been confusing each other. And if it's happening more than 5 times, I want my rule to trigger. And I could use that, for instance, to auto-terminate my training. You can run this rule locally. How you do that is, again, you create a trial and you pass the trial object into your custom rule. And then SMDebug provides a function called invoke rule that you run. And in my case, I see now that the rule triggered at step 8758. You can now run this custom rule also as part of your SageMaker training. In order to do that, you have to provide a rule configuration, which is basically you take the code snippet and save it in a separate Python file. You specify the compute instance you want to run this rule on, and then an image URI. We provide in our deck documentation all the available image URIs where you can that you can select depending on the region you are running in. And once you have this custom rule, you can just pass it into your training, and now your training will run with this rule. So now I would like to go to the last use case and talk a bit about the XGBoost report rule. That's a relatively new feature that we have introduced, and it creates automatic visualizations for XGBoost model training. In order to select this rule, you just have to instantiate the XGBoost report rule and pass it into your XGBoost model training. That's all you have to do. Once the XGBoost model training finished, you will find a static HTML report that gives you a lot more insights into your model. You find this static HTML report in your S3 bucket, and I have downloaded it from my S3 bucket. And this is how the report looks like. It will give you some information about, for instance, the distribution of true labels in your dataset. That gives you some insights on whether your dataset has been imbalanced. It then also provides a loss versus step graph. So for instance, here we see that the model has been overfitting because my training loss is decreasing, but my validation loss does not. The report will then also include some information on what you can do to avoid this problem. So in case of overfitting, it will tell me the kind of hyperparameters I can tune, as well as other actions I should take. The report also includes some visualization for feature importance. So in my use case, I have been training on a data set that provided 30 features, and obviously my second, first, and feature 0 are the most important ones. The report also provides a confusion matrix to show how well the classifier is working. Then also an evaluation of the confusion matrix. And furthermore, you will also find ROC curves that tell you how well the classifier worked, as well as the distribution of residuals at the last saved step. Okay, so that's all that I wanted to show in my demo. So let's go back to the presentation. If you would like to learn more about Amazon SageMaker Debugger, then I recommend you to check out our tech documentation or our paper. We recently published a paper about Debugger that explains the debugger architecture, as well as all the different built-in rules that are available, the kind of issues they can detect, and how you can mitigate those problems. So feel free to check out this publication. Thanks a lot for attending this webinar.